Everybody, welcome back to another fun and exciting Algebra 2 class. Can you believe it? We are ready to start lesson or chapter number 8. We're cruising through this book, and we've only got a few chapters left. There's only 12 chapters in the book, so we are coming near. We're over halfway done, so keep working hard. This lesson is starting on page 372. Page 372. 8.1 Angles and Triangles. We're kind of like I said before, what we're doing is we're exploring different branches, if you will, of mathematics here in the last half of Algebra 2. We kind of explored the branch of logarithms and exponential equations in last chapter. This chapter we're going to be talking about trigonometry. This is almost like pre-trig. Okay, there's no such class as pre-trig, but this lesson, this chapter, and really the next chapter too, these two chapters are really crucial, vital to you having success in trigonometry class. So if you're planning to take trigonometry, these next two lessons are very, very, very important for you. If you're not planning to take trigonometry, they're still very important to you because these are like the core things that you really need to know about trigonometry just in your general life through different standard tests that you'll be taking, college entrance exams, things like that. So very important stuff right here. So you need to pay attention. Chapter 8, Lesson 1. Angles and triangles. Let's talk about some things. First of all, what in the world is trigonometry? We need to know what it is. All right, so if we're going to study it, we need to know what we're studying. Trigonometry is the study of triangles. Then I wrote especially right triangles and related functions. What does that mean? So basically, we dedicate an entire year to studying right triangles and their related functions. What does that mean, their related functions? Well, here's what it means. We are going to learn, maybe you've looked on your calculator and you've thought, what in the world does this button mean? You've seen the one that says sin, S-I-N, and you thought, boy, I better not touch that. Maybe I'm going to be sinning if I touch that button. You don't want to sin, right? So that's not what that means. It doesn't mean sin, okay? It has nothing to do with doing bad things. That means sine, and we're going to learn what sine means and how to use sine. Maybe you've seen the one that says COS, cos, and you've wondered what that means. Maybe you've seen the one that says tan, T-A-N, and you've wondered what that means. Well, we're gonna solve that mystery during this chapter. We're going to learn what those different things mean. Those are what's called functions of trigonometry. They're right angle functions. And so we'll learn all those things and kind of figure out what that means and how these are going to work and how we can use them in life. All right, let's talk now about the history of measuring angles. To me, this is pretty interesting. I like history. I'm a history guy. That's kind of my second passion to teach is history. I love teaching about history and geography and different things like that. Well, in math history, there's some interesting moments in history, and one of the most interesting moments in history is these guys, the Babylonians. The Babylonians, way back, thousands of years ago, okay, before Christ, they came up with this idea of they were measuring the sun going around in the sky. And they came up with this idea of 365 days in a year, right? That's what we use. We still use their calendar today. We use the Babylonian calendar, 365 days in a year. Why? Because it takes basically 365 days, and then you have leap years in there every 4, and a quarter is how it works, to rotate around the sun. Well, it was a little bit difficult to use 365 in the calculations. It was much easier to use a number that had more divisibility in it than 365. Basically, 365 is really only divisible by 5. So what they did was they decided that they were going to use 360. So 360 degrees. And that is the number of days, if you will, for the Earth to revolve around the sun. So every day is a degree. The sun moves in the sky. Now, you understand that we're moving. The sun's not moving. We're going around the sun, right? The sun's not the one moving. It looks like the sun is moving, but the sun is not moving. We're the ones that are moving. And so 360 degrees, 360 days to revolve, to go around the sun. So what's going on here is they kind of tied the two concepts together. So now when we have a circle, we have 360 degrees in the circle. Every degree, so let's say that we put a line here, and then we put a line here. That's going to signify 1 degree. And there would be 360 of these in a circle. Now, my circle doesn't have that many, but let's just pretend. 360 of those in a circle. 360 1-degree revolutions. So every day the sun moves 1 degree. And so that's where that came from, the whole 360 idea. So some of you always wondered where that came from. Some of you have never wondered where that came from. Well, now you know, either one. All right, so now the next thing I want to talk about is naming angles. How are we going to name angles? So let's start with this. In geometry, and there's a connection between geometry and trigonometry. So geometry is the study of all shapes. Trigonometry is like a study inside of geometry. It's like you pull one shape out and you say, okay, I'm going to study just that shape. And that's trigonometry. So geometry is like the parent, if you will, and trigonometry is like the child underneath of that. So in geometry, there's a concept, and here's the concept. Every drawing starts with one thing. You taking your pencil. In my case, that's not really a pencil, right? I don't even know what that is. I think it's called a stylus, okay? So you take your pencil. In my case, I take my stylus, and I put it on the screen, or you put it on the piece of paper. What does it create when you put it down? It creates a point, right? So every drawing, every geometrical shape, everything, every letter, anything that you draw always starts with what? It starts with you putting your pen on the paper, okay? So everything starts with a point, okay? In geometry, that point is called, guess what? This is epic right here. It's called a point. Yeah, the point is called a point. So that's pretty, it's crazy, right? Now, when we're dealing with an angle, so if we start with the point, and then we draw our angle from that point. So there's one side of the angle, and there's another side of the angle. Well, this point right here has a different name when it's part of an angle. This is called the vertex. It's called the vertex, and that's very important to understand and know that. So when I say vertex, you need to know what I'm talking about. I'm talking about a point, but I'm talking about a specific point. It's a point that the angle comes from, or comes to a point, comes together right there at the vertex. Okay, so we're going to use that quite a bit. Vertex, make sure you know that word. So when we name angles, we name them with the vertex. And if you look in your book, you can look on page 373. So let's name this. Let's call this ray right here, or this line, let's call this the X line. And then we'll call this line down here the Z line. Let's name the vertex Y. Okay? Y? I don't know. I just want to name it Y. All right. Y is a letter and a question. So now I'm going to name it Y. I can call this angle right here, I can call it different things. I can name it differently. One name that I can name it is I can name it angle Y. I can name it after the vertex. I can just say, okay, that's angle Y. And I know what angle I'm talking about. It's the angle based on the vertex. A second way that you could name this angle is you could name it with the sides, the vertex, and then the side. Okay, so what do I mean by that? I could call it X, Y, Z. X, Y, Z. Another thing that I could call it is I could start with Z, and I could say it's ZYX. I don't know why you would do that. unless you are like me and dyslexic. I'm dyslexic, so I confuse things. Like right there, I just wrote a Z instead of an X. So if you didn't know that about me, that's something interesting, that I have dyslexia. Some of you use dyslexia as an excuse not to be good at math. It's not an excuse to not be good at math, okay? You need to overcome your weaknesses. And you can be good at math even though you have maybe some math disabilities and learning disabilities. So XYZ or ZYX, you can name it either one. What I cannot name it is I cannot name it angle YZX. I can't start here and then go here and then go here. I can't start there and go here and then go there. I can't start at the vertex. Okay, so that one doesn't work. I have to either name it the vertex, or the vertex has to be in the middle because the vertex is in the middle. Okay, so that's very important to understand as we're going through these. All right, next concept, if you want to go ahead and turn the page over to 374. 374. We're going to classify some angles. We're going to talk about what different angles, what would we call those? What do they look like? The first one that we want to classify is what's called the acute angle. And I like the cute angle. I call him the cute angle because he's cute. Why is he cute? Because he's little. What does acute mean? Here's what acute means. Acute means less than 90 degrees. Okay. What's less than 90 degrees mean? Well, 90 degrees is straight up and straight over. So that's 90 degrees. Okay. So if you have an L shape, that's a 90-degree angle. So it's less than 90 degrees. So what does it look like? Well, the acute angle looks something like this. And you can have different types of acute angles. I mean, you can have anything from this to about this. You go right there, and now you've got a right angle. So it's got to be less than a 90, but anywhere in there. Those are all acute angles, wherever you put that. Okay? So there you go. There's an acute angle, less than 90. The second type of angle is an obtuse. Okay? An obtuse is more than 90. More than 90 degrees. Okay, so what does obtuse look like? Well, obtuse kind of looks the same as far as where you start. So there's my starting point. And, okay, so that's acute, acute, acute. That's right. That's at the L shape. And now we're past the L shape. We're bigger than 90, okay? And so somewhere in here. And I want to add to this. So it's more than 90, and I'm going to put but less than 180. And we're going to see what 180 looks like in just a second. But obtuse is more than 90, but less than 180. Okay? All right, right. And these are all classified in your book. They all go through there, and it's on page 374 and 375 in your book if you want to look there. All right, so a right angle is 90 degrees. We've already talked about the right angle. So this is the one that we're actually going to be studying quite a bit in trigonometry, but it's an L-shaped angle. Looks like an L. The straight angle. I kind of referenced this just a second ago, but let's take a second to talk about it. The straight angle equals 180 degrees. 180. What does 180 look like? Well, 180 is half of 360. So if 360 is a circle, so let's put our, let me show you this real quick. So let's put our line here. And if we take our other line and we go around a circle, that's 360. So what is a straight angle? Well, it's like that. It's half of a circle. So there's your circle going all the way around. Your straight angle goes halfway around. And so obviously you'd have a vertex right here. Okay? And so the straight angle is 180 degrees. In essence, it's a straight line with a vertex in it. That's what a straight angle is. The next one is called the reflex angle. And reflex angle is interesting, but I'll write it like this. It is the backside of an acute angle. Really, it could be the backside of an acute or obtuse. Okay? What do I mean by that? Well, it's the backside of the angle. So let's draw the angle. Let's put our vertex here. And let's just draw, sorry about that. Let's just draw, there we go. Let's draw that. Now, this is the backside of this angle. This is how we draw a reflex. We're not talking, let's call this a 30-degree angle. We're not talking about this angle, the 30 degree. Okay, we're not talking about that. We're talking about this one back here. If that is 30 degrees, guess what the reflex angle is? Well, the reflex angle is the rest of the circle. So we take out the 30 degree. What's the reflex angle? It's 360 minus 30, so this would be a 330-degree reflex. 330. How do you get 330? Well, I take my 30, that was the angle, and I subtract it from 360. Why from 360? Because that's the complete circle. The circle has 360. So that would be a 330-degree reflex angle. All right, just a couple more things that I want to get to you in this lesson. I'm going to break this lesson into two, an A and a B. So just want to get through this last part. And this is called angle pairs. Angle pairs. What do I mean by angle pairs? Well, a pair of something, it's two of something. So what do we get when we have two angles together? So if I have one angle, and here's my angle, all right, so there we go. There's one angle. Now, if I have a pair of angles, that means that there's another angle somehow connected here. And it could be right there. It could be there. It could be there. It could be wherever. I'm going to put the other angle right there in the middle. Okay? Now, I want you to see what I created. I created one angle here. I created one angle here, the big angle. I created one angle here. I really have three angles there. Okay, so I have 1, 2, and then the big one, 3. Okay, everybody see that? Yeah. So those are what's called adjacent angles. What does that mean? Here's what the word adjacent means. It means that they share a side. They share that side. That is an adjacent angle because it shares the side. This would be the adjacent side. Okay? Why? Because that's the side that it shares. That one is contained in both angles there. That's the adjacent side. Okay? And these are in your book as well if you want to look in your book. The next one is what's called complementary. Now, the complementary are adjacent angles. So these ones really fit under, sorry about that. These ones basically fit under adjacent. So I could have made these like A and B under adjacent, but I just made them 1, 2, and 3. And here's what it is. A complementary angle is a right angle. Okay? Let me do it like this. Before I write that, let me actually write what it is. I'm going to write a definition. Two adjacent angles that equal 90 degrees. Two adjacent angles that equal 90 degrees. What do I mean by that? Well, here's what I mean. If I have my angle, my right angle, my 90 degree, and then I have an adjacent side somewhere in that 90 degree, okay? Wherever I want to put it. I could put it there. I could put it here. I could put it here. Doesn't matter where it goes. That is called complementary. Why? Because they add up to 90 degrees. In other words, those two together, when I put them together, equals 90 degrees. All right, the last one is the supplementary angle. What does that mean? Well, the supplementary angle is two adjacent angles that equal 180 degrees. So now in supplementary, and it's different than complementary. Complementary, everything's the same. Two adjacent angles that equal, look, the difference is 90 and 180. So the complementary is a right angle, and the supplementary then is a straight angle. So if I have a straight line, and then I put a point in the line, and at that point, then I have my other side. Okay, and you can put the side wherever you want it. The side could go here, the side could go here, the side could go here. The one place the side cannot go is at 90 degrees. That is not what's called supplementary. This is a little different because it's a special angle. 90 degrees special angles. They have a different name for it. We'll cover that later, especially once we actually get into trigonometry class. But for right now, it's fine where if you have anywhere from basically a 1 degree angle all the way to a 179 degree angle. Anywhere in here, you can put your other line. I'll put it right here. Okay? And in this case, maybe we have a 130 degree angle. And remember, it's a 180, so this one would have to be 50 degrees over here. Now, when you add those up, you get 180, and that is supplementary. All right, that's all I have for you today. I hope you were able to understand most of that. Most of that was just content where I was just kind of helping you understand vocabulary and different ways of identifying things. If you missed anything, make sure you slide it back, watch it again. All right, that's all I have for you in this lesson. We'll see you later. Have a good one. Bye-bye.